Welcome to the Evolution Show. I'm Johan Landgren. Today I'm back for another inspiring conversation with the CEO and founder of the world-leading electric plane developer, Heart Aerospace. If you missed the previous episode, you really should check it out to learn more about Heart Aerospace and what the company has going on. Today we take a closer look at the Heart ES-19, the 19-seater electric plane this world-leading electric plane developer is developing here in Sweden. That is to be commercially ready and certified already by 2026. And if you like the content and you want to support the show, we really appreciate a thumbs up. And consider subscribing. As always, stay ahead of the curve and stay electric. This is the Evolution Show. Welcome back to the Evolution Show, Anders Forslund.
Thank you. Great to be back.
Yeah. In the previous episode, we talked about the progress you're making at Heart Aerospace, developing the world's fully electric commercial 19-seater airplane. And in electric aviation, we talked about the possibilities already today for regional travel. And in this episode, I thought we could talk more about the plane itself. The Heart ES-19 plane, which is the name of Heart Aerospace's first electric model. But for those who did not see the previous episode, could you briefly tell us a little bit about the plane and a little bit about Heart Aerospace?
So Heart Aerospace is a Swedish startup that's building an all-electric plane. The aircraft is called the ES-19, and it's a 19-passenger aircraft propelled entirely by batteries and electric motors, and something that we're targeting regional routes. We hope to have this. We're working to have this aircraft ready and in commercial service by 2026.
Yeah, and the ES-19 it has a range of approximately 400 kilometers or 250 miles. Excluding a reserve, I think about 100 kilometers, if my memory serves me correctly. Is that correct, or is it something like that?
Yeah, I mean, the 400 kilometers, really depending on which battery technology we're using, but you have to then count the reserves and some of that stuff. So you actually end up flying routes that are shorter than 400 kilometers. And we're seeing, as I mentioned in the previous episode, that the interest here, so the early adopter routes will probably be around, a little bit north of 200 kilometers.
And in the previous episode, we talked a little bit about United Airlines and the Mesa Airlines, which have, 2 orders of 100 planes each. And we talked about also regional travel. So I encourage people to check that episode out to learn more about that. But what kind of market do you see for the ES market, for ES-19 plane with the current battery range technology?
Yeah, I mean, there's 2 markets that we're very familiar with, or there's many all over the world, but the one is the route network in Norway, which is a lot of short routes that are being flown by very old aircraft, a very small turboprop aircraft that's being subsidized by the government. We're also seeing in the US to reinvent regional air travel in 19-seaters as it was a few decades ago, where there was hundreds of 19-seaters flying across the United States, serving hundreds of communities that have since lost all of their service. And the average route length for that was about 150 miles, 270 kilometers. So there's definitely, like the ES-19 as an aircraft is not a long-range aircraft per se. It's sort of a commuter aircraft category. And what we're really focusing on is not range, actually. It's about getting the unit economics for flying these short routes so that they can become economically viable.
Yeah, and I think you looked at Sweden and Norway, and already in Sweden and Norway, obviously, there is a market for this. So in terms of percentages or in terms of market share in the domestic kind of traveling in Sweden, how much share of the traveling of the aviation can you take in Sweden?
Yeah, I mean it's a really interesting question. So if you were to look at, this is a lot of people get this wrong. Like if you were to look at, let's not talk about Sweden, but let's talk about the US because I have it more fresh in my memory. People can look at that map and say, there's almost no 19-seaters flying in the US right now. It's a very diminishing market share. And you end your analysis there. But actually, if you look at the pent-up demand, even just looking a few decades ahead, you realize that there is actually a large market for this, and operators know it, and it's just that the unit economics are not working. So that's one thing. I think what we're talking about for these early routes of 200 kilometers and 400 kilometers, it's in terms of the overall emissions of aviation, it's still single-digit percentages. But actually, a large portion of aviation is actually from the short-haul flights as well. So about 1/3 of the total emissions from aviation is coming from routes under 1,300 kilometers. So our ultimate goal by 2050 is to start addressing those routes. So we don't think that electric aviation is the solution to, in terms of being there for the climate, for the zero emissions goal by 2050. We don't think electric aviation is the solution for say, transatlantic flights. But we think it's a really important part of getting these short-haul flights to be 100% green and also and propel that by this better unit economics, which I think is really important to sort of supercharge adoption of a new technology.
Yeah, you've decided to go with a more traditional design and the 19-seater, which is, I think, a smart one. You talked about it in the earlier episodes about in terms of choosing this route because of certification process and so on. And of course, the battery technology we have today. But of course, a lot of people that watch this might think, yeah, but there's a lot of other companies now going for the VTOL, electric VTOLs like Lilium and Joby Aviation and so on. So just briefly, could you tell the difference so people understand? This is obviously a traditional plane, but what's the benefits with going with the traditional planes aside from, compared to a VTOL, for example?
No, I think there's a lot of exciting developments in VTOLs, and it's something as an engineer I'm pretty excited about, and I was very excited about when I got started about this as well. I think there's many revolutions coming to aerospace. Some of them we talked about for a long time, like, well, electric propulsion is one, increased autonomy is one, vertical takeoff and landing is one, and then new types of air traffic management is one as well. But these are all things that, has never been done or only demonstrated on military aircraft or stuff like that. So they're very challenging. And so we don't want to be doing 4 challenges as one. We want to focus on just the electric propulsion system. Because aerospace is hard enough, and it's a long leap from having a technology demonstrator to actually having a certified aircraft. And secondly, I think it's really important, like we care about safety, reliability, and unit economics. So airlines, if you can transport 19 passengers with 2 pilots, that's much better unit economics than if you transport 5, right? So those are the metrics that matter. And also from a sort of a battery point of view, there's some interesting trade-offs there because if you're there's the energy density that I think many people are aware of, but there's also power density, and power density is a limiting factor of energy density. So you can have an aircraft that's has a very, very high energy, but then the power draw is limited, and by going with a conventional design, you're actually much kinder to the battery, so you can pick a different chemistry that is actually more optimized. You can get better range. So it is a little bit of a trade-off that we're making there.
Yeah, and obviously you can take 19 passengers, which is the most of the VTOLs. We're talking about 4, maybe 6, maybe a maximum 8. I haven't seen one with 8. I think 6 is the maximum I've seen. So that's also obviously a benefit with going with with your design. But if we think about reaching the goal of delivering these planes in 2026. how do you plan to scale up the production and still maintain the quality, which of course is the biggest challenge, as I understand it. Elon Musk often talk about this,
with cars.
He realized after, you know the whole story. So do you plan to use partners, or you're going to eventually have to build your own factory to put these planes together?
Yeah, so we're using partners for an aircraft is essentially a Lego kit, very distributed network. So we're tapping into that same supply chain that many of the large OEMs and also the people that are building smaller planes are doing. And aircraft are not, exactly, you cannot sort of equate mass production for an aircraft. A good regional aircraft is the one that you're selling, a few hundreds or maybe a few thousands of. Whereas, a Model 3 is something that you want to build millions of, right? So it's a little bit, it's not this sort of Henry Ford production. Obviously, there's really interesting things to be done there, but ultimately it's about tapping into that supply chain. But on the other hand, it's much more regulated. So it's the production organization approval that you need in order to assemble these and build these and all of the other approvals that you need for maintaining continuing airworthiness and all of this stuff. So I think that's another reason of sticking with a conventional design, is that you can those processes are already in place.
Yeah. And I know that you have talked about it a lot, and I think it's a really good point here to pinpoint as well, that in order to make the Heart ES19 affordable as well as ready for the market as soon as possible, bearing in mind all the certification processes and so on that you have in the airline industry, aviation industry, you have decided to streamline and simplify as much as possible of the design, and to to avoid reinventing the wheel, so to speak, something we spoke about in the previous episode. And right now, much of your innovation goes into what's called the nacelle on the airplane. So can you tell us about that?
Yeah, under each wing, under each wing is two nacelles, so 4 total in the plane. These nacelles carry about the same amount of energies as 2 Tesla cars, and the entire novelty of the aircraft is in those nacelles. You have the batteries, the charge port, the power electronics, the motor, and the propeller. So the rest of the aircraft can be a standard airframe, standard aluminum airframe. So this is a way for us to modularize, compartmentalize the risk, and having that demonstrator that I'm showing behind me that actually demonstrates that. And obviously I'm a big believer in reducing the complexity of any design. I think it's absolutely paramount to make this a reality.
Yeah. And since you want to have this out on the market as soon as possible, and in bearing in mind the climate crisis and everything, I think it's a very smart move. But if we talk a little bit, I just came to think about this. Obviously, you must have thought about this, but I'm also very interested into solar energy and solar panels and so on. And I thought, like, maybe in a future model you could integrate, solar panels either in the nacelle, onto the nacelle, or not the nacelle, onto the the wings. And into the rest of the body of the plane. I know that you want to keep down complexity, so I guess that's nothing. It's not something you're thinking about right now. But is that a possibility, or in the future, or what do you think about that?
Yeah, I mean, the problem with solar cells is that there was an aircraft called the Solar Explorer that crossed the Atlantic, electric plane. It was a solar plane. It had the wing area of a jumbo jet, and it had 1 passenger. And it was actually that's the sort of ratios that you get. So actually putting some solar panels for in-flight adds weight, adds complexity, and doesn't boost range that much. And also only really give boost ranges if you're doing a daytime flight. So it is. We've seen some of our competitors put solar cells on their wings, but they've since removed them because I think that it's just it's a necessary complexity. What you should do is to put solar cells on the airports.
Yeah. That's a good point, and of course we'll see how the solar panels, they are getting more efficient and so on, and lightweight and so on. So we'll see the future materials might be interesting. But I understand your approach. I was actually guessing that's what you were doing. But it's always interesting to hear how you think about these things. Yeah. One comment I got from the last time actually you were on the show, one of the subscribers, or one of in the comment section, the question goes like this: understanding that you don't need full power during the whole flight, but what would, for instance, be the difference in energy consumption during the cruise compared to the takeoff?
No, that's really good. So for the takeoff, we're running about between 300 and 400 kilowatts in each nacelle. So if we do fast takeoff, it's 400 kilowatts, but we can also do 300 kilowatts. And at cruise, we're at about 125. So it's quite a substantial difference. And then at descent, we're actually running, applying almost zero thrust or energy into the propellers. I mean, we can even go negative and recharge the batteries, but that's sort of a loss of thermodynamics thing that you cannot actually gain energy by doing that. But you can actually, it's only if you're in a place where you have a steep approach, or if you have other reasons that you want to do that and increase safety. It's really interesting. It's called regenerative soaring. So.
Yeah, and another question I got was actually from my previous guest, Linnea Corneyhead. I asked her if because she's the co-founder and chief marketing officer of this company, Einride, developing self-driving electric trucks. And she said she was wondering, she really likes Heart Aerospace and what you do. She follows you closely. So, but she said that perhaps something about what's the next big thing, or something about are you expanding into other countries in Europe? I guess you are already offering that to other outside the Nordic countries. What can you say about that?
Now we're speaking to airlines all over the world, and we some of them want to go public with LOIs, and then we say, yeah, fine, if you want to market this. Some of them want to stay under the radar a little bit. But we can do either or, and we're seeing this like across Europe. There's this, in France, short haul flights were banned by the government due to climate. If you can take a train in 2 hours and a half, you're not allowed to fly. We've seen in Austria, there's been legislation that has essentially shut down all short haul operations of turboprops. So there's definitely a large market, not only in the Nordics, not only in the US. But all over the world.
Yeah, and just if you look at the plane, if you talk about energy consumption a little bit, you've designed the plane, the Heart ES19, to have 4 electric motors instead of 2 larger ones the traditional planes have today. Briefly, could you just tell us why you have chosen this path?
You want to have as big propellers as possible. You want to move as much air as you can, as slowly as you can. That's how you get the best trade-off between kinetic energy and momentum. So if you put 2 really big propellers on a high-wing plane, they will hit the ground. So getting 4 of them is better. You're also reducing the size of the motors, which is good for cooling of the motors. And also, you have to certify against 1 motor failure. And if you have only 2 motors, you have to certify it for, you have to dimension it so that the one of the motors can go to 200%, or both motors can go to 200%. Whereas if you have 4 of them and you lose 1, it's only like 133%. So that reduces the scale of your entire system. And also the imbalance load of losing 1 motor is different, so you're actually creating a smaller tail fin of the aircraft as well.
Just an overall question I think people think about. I mean, what do you see the biggest challenges from your perspective to develop an electric plane? And can you perhaps share some of the ways you have been able to address some of the major issues, or some of the issues you have seen so far?
No, I think the major challenge of doing is that this is such a complex product, and it's one of those things where you can get 99 out of 100 things right and on schedule, and you miss one thing, and you cannot start flying. If one of your systems is delayed, or one of your suppliers is delayed, or all that. So that becomes, it's about risk mitigation. And I think I'm really like an adamant believer in the sort of risk upfront. Building prototypes, I really like. There's been a lot of hype or a lot of movement in the industry towards virtual tools, which this is what I did my PhD on. I'm a big fan of virtual tools and simulation, all of this stuff. But there's nothing that actually beats having a prototype. So I think going to prototypes fast, going to them early, learn your lessons. I tell my team, if you're building a prototype and it comes out exactly the way you wanted it to, there's no point in building a prototype. Like if you don't learn anything by building the prototype, then you've already had the correct design in your head. Then you waited too long to build that prototype. You want to build it to figure out what you've thought wrong, and so you have to start doing that very early on. And that's a mindset that we're instilling here.
Yeah, and sort of a final question, what do you hope to achieve with your electric plane, other than reaching, of course, the goal of having it commercially ready and certified by 2026? I mean, do you think, can you help push the aviation industry towards more electric and fossil-free technologies faster, for example, like in a similar way like Tesla has done with the electric vehicles for the auto industry?
Yeah, I think so. I think that electric planes, what we're doing here with the traditional regional route electric planes, there's many new technologies coming out there, novel designs of planes. I think this has the potential to be the first zero emissions technology that's out there. And not only is it a great technology that's applicable for different types of propulsion systems, it's only just a catalyst effect of breaking through, of getting something through certification so that people can start experiencing it. I think that's one thing that you've seen in technology. As soon as one person or one company proves that something is possible, then it's sort of that limit that we put on our shoulders disappears, and then you start seeing this sort of effect of more people coming along. And ultimately, the sad thing about aviation is that all technology, if you don't reinvent yourself, if you don't maintain it, it's in a state of decay. There's many examples of aerospace companies worldwide that have shut down. If you can go to EASA, you can see everybody that had a design organization approval that no longer has it. There's a generation of aerospace engineers that are being retired. So we want, it's about sort of, keeping that momentum going, keeping aerospace alive, finding people that can not only sort of do incremental improvements of what's already there, but building something from the ground up. So it's as much about building that company as building the plane.
Yeah, I couldn't agree more, and I love to see what you're doing, and I think you're doing really well. I just hope you continue and keep up your power and energy to push forward. And, and finally, since the Evolution Show is about inspiring positive change, I repeat the last question I gave to you in the previous episode. So if anybody is interested to be part of Heart Aerospace, your journey you're on right now, either at maybe looking into getting a job or helping in any way to push this development with electric planes, what's your advice, and are you hiring people right now?
Yeah, we're hiring. Check out our website. So there's we're really ramping up. And if you're not, if you're younger, or if you're looking to get an education in aerospace, start reading up on this stuff. I started tinkering with drones actually when I was quite old, but got really into that. And there's so much opportunity. I think the barrier of entry to getting into flying vehicles has never been lower, and it's fun. It's really fun, and I think that's one of the things that is driving me every day, is just the sort of excitement I get about being around this technology and being around the people, learning from expert, and actually having people come work with you that have been on this journey many times before and learn from their experience. So I think it's part of my, part of the things that we want to do is also make aerospace approachable and make it accessible to people. so I try to, maybe when I talk about this, people will think that I think that aerospace is something that's very, very simple, because but it is not. It's very complex. It's very hard. It's very regulated, and that's why we should try to get rid of that noise and find that simple explanations for how very complex things are done. I think that has a very inherent value.
And I think that's a great ending note, to get rid of that noise, because that's you know, what Air Electric planes can do. One of the many things they can do. Thank you so much, Anders, for this update, sharing your journey, and I hope to have you back on this show another time to hear more about what you're doing. But thank you.
Thank you. I can say as a final thing that many of my employees, the people that I've hired, watched the last show, so it's actually it's a good marketing tool for us to get employees here. So I hope we have the same effect for these episodes. So thank you.
Glad that I can help and be a little part of your journey as well, because that's my intention also to push as much as I can. So yeah, thank you so much, Anders.
Thank you, Johan.
I hope you enjoyed today's episode. Tell us what you think in the comment section below. And if you like the content and you want to support the show, we really appreciate a thumbs up and consider subscribing. Up next, I will have several episodes with a super cool solar entrepreneur and inventor in California that is developing a solar race car with a team in Mexico. My secret guest will be joined by some of the leading members from his solar race car team to share more about the project. So stick around for that. As always, stay ahead of the curve and stay electric.